Today, we will be talking about failure in nephrogenesis and sex determination in female mice. Nephrogenesis is the development of the kidney in the embryonic stage. It consists of three stages: pronephros, mesonephros, and metanephros. Improper development of the kidney is caused by non-viable WNT4 genes. Both failure in nephrogenesis and sex determination is caused by different paracrine factors and signaling pathways. Inducer molecules are tissues that produce signals in cell-to-cell communication. An example would be paracrine factors. So what are paracrine factors? It is a diffusible protein which is released into the immediate space to induce changes around the cells that produced them. There are four different families of paracrine factors: the FGF family, HH family, WNT family, and TGF-beta family. The fibroblast growth factor family is highly conserved in both gene structure and amino acid sequence and is associated with developmental functions. FGFRs are set or receptor tyrosine kinases. They are activated by the FGF family. Each FGF has their own separate functions. HOP family is important for vertebrate limb and neural differentiation. It works with other paracrine factors such as WNT and FGF. Only the sonic and idiot hedgehog are expressed in the kidney. WNT proteins consist of cysteine-rich glycoproteins. They play several roles in the development of the urogenital organs and are necessary for kidney development and female sex determination. WNT proteins have many functions regarding development. Body axis patterning is an important step in establishing the overall body plan of each individual organism, such as the antero-posterior axis, the dorsal-ventral axis, and the right-left axis. Another function of WNT protein is regulating cell proliferation, which is the cell growth of embryonic stem cells. The third function is cell migration, which occurs during embryonic development and allows the establishment of body axis, tissue formation, and limb induction. The last function for WNT protein is cell fate specification, or also known as cell differentiation, which means that unspecialized cell becomes a more specialized cell type. TGF-beta family is a family of structurally related cell regulatory proteins and is critical in controlling when the epithelial cells can branch to form the ducts of kidneys. TGF-beta family is categorized into four major subfamilies: decanter-pentaplegic VG-related, DVR-related subfamily, activin-inhibin subfamily, TGF-beta subfamily, and divergent members including the Mullerian inhibitory factor. So what is the role of the TGF-beta family signaling in metanephric kidney development? GDF2 is involved in the regulation of kidney organogenesis. Activation of GDF2 expression in mesenchyme cells initiates the reciprocal inductive program, leading to formation of the kidney. Deficiency of GDF2 leads to uni or bilateral kidney agenesis. TGF-beta2 is involved in induction of metanephros, which is one of the stages of nephrogenesis. The loss of this growth factor gives rise to incomplete penetrant kidney agenesis in females, meaning that the genes of the kidney do not express some of the characteristics of phenotypes that is thought to express in the kidney. BMP4 is involved in organogenesis of the kidney, meaning that it aids the production and development of the organs in the embryo. It controls the medullary smooth muscle cell differentiation in the embryonic kidney. BMP7 is involved in organogenesis of the kidney and is a survival factor for nephrogenic progenitor cells. Without it, the kidney does not develop, and nephrogenic mesenchyme cells will deplete. Another factor would be the SMAD4 factor. The loss of this factor results in the loss of the metanephric mesenchyme, which is one of the two embryological structures that give rise to the kidney and the ureteric bud. So how are WNT4 and BMP4 related to nephrogenesis? Smooth muscle cell differentiation in kidney is controlled by WNT4 via BMP4. Both WNT4 and BMP4 rescues alpha SMA cell differentiation. Without it, endothelial cells in the WNT4 deficient kidney will develop secondary defects in its maturation. Paracrine factors act through signal transduction pathways.
Created using Powtoon.